Doing this since 2015. So if you look up there on that part of the screen, boy, look up there. That's stellarium. It's on the laptop here. So stellarium is what people are using to kind of tell what to look at, because these new telescopes, you have to know when something's coming up and where it's going to be in the sky. If my sea star is there and it's over here, it ain't going to see it through the house. So you've got to know when something's there, whether, what time, and what date. So this is where naked eye astronomy does come in. You should look up as much as possible and learn the sky. And we talked about that getting ready for the eclipse. Learn the Big Dipper and the Little Dipper. And Little Dipper is part of Polaris North Star. And then near them is the royalty of the sky, which is the king and the queen. So once you get that down and you know it well, then you can start working out from there. But that's what I would recommend that you look at all summer long. And wherever you go, look up at the sky. In Florida, look up at the sky. In California, look up at the sky at night. The sky is going to be different. The times will be different, and so on. So what Mecca publishes is this here. Every week we publish this here, and most of this comes from Cambridge Press, which is one of the world leaders in astronomy stuff. So Lisa here, who's been helping us, does this every month. It's published monthly, and it has in there the constellations to look at for this month. Okay, and we have it published for May and for June, because those are the ones, and we're already in July. For those who are going to want to learn this is the best magazine called Sky and Telescope. It's been out for many years, and it's very, very well done, and goes through a lot of knowledge that you should have, plus hints for this month. How to use binoculars this month, how to use a telescope this month, and what to look for. Moon, planets, stars, deep sky objects, and so on. Plus, it's very well done as a digital. So I get the digital edition 2 days before this comes in the mail. So there's a lot of people out there publishing stuff. If you want to communicate with us and say become part of our network, on here, for sure, on June 14th, we would like some people working with us. So we do have 5 dwarf users, and in hopes we can get some of them working. So there's one other thing I wanted to try to cover here to wrap up. So I'm trying to think. I guess I've gone through it all. I can't think of anything more at this point. So there's one other device I want to cover. Give me that. Let me see. And you can see it's very important when you buy these things that you get a good case. And then you have to make the decision on a hard shell or a soft shell case. As a general rule, a hard shell case is better, more protection than a soft shell. Oh yeah, I know what one. There are other spectroscopes out there that are easy to use. This one is made by, I think it's Harvard University. And they're made for the educational world. So when we talked about that angle, that's where the angle comes in. You're going to look through here, okay, but you're going to see your spectrum. That's what I wanted to cover. You're going to see your spectrum in here, and it will have the colors and the numbers in nanometers, okay? So she just left, and I hope she comes back. So what I wanted to get across, now let me think how to do this. Draw down at the bottom a circle for a light source. Okay, now, up above there, draw a flat plate above the circle. Okay, now, to the right of it and to the left, draw another flat plate. No,
Oh.
all in line.
Okay, we're just gonna.
No,
Like,
they've
oh,
all-
this
they've got to be
way.
the same. 1, 2, 3.
It's fine. I don't.
Okay. Now remember when I told you the light goes straight? That's very important. In radio they call it line of sight. In drones it's line of sight. So it'll go straight. But now we're going to do something. We're going to reflect it, refract it, or diffract it. So in this case, we're going to put a diffractor in the middle there. Okay. So in front of the circle, put a flat thing. Just a flat. Or a lens. Something in front of the circle. The circle is your light source.
Here.
Yeah, in front of the circle. Now, here, let me think how to do it. This is kind of what I want you to draw. You have a light source somewhere here. You're looking at it. The diffractor, if you look straight, Lisa, listen now. If you look straight, you're going to see more than likely just white light. You got it? Okay. Now, on this side and this side, if you saw that split, it's going to split. It's going to split to the right and the left. So when you look in here, if you look into the star there, you're going to see it over here because, as I said, that angle is important. So anytime you're diffracting light, there comes an angle. So when we're looking straight at that, what you're going to see is not straight on. What you're going to see is over here and over here. Everybody got it? This is called the maxima. So this is where you're going to learn lots of terminology. If you want to work in a hospital, you have to take the whole course in medical terminology before the sales people let you work there. You know, cholecystectomy, oophorectomy, all these Latin words and so on. So anyway, this is called your first order spectrum. And then you may have more of them, more. You can have multiple slits. You can have 2 slits or 5 slits. But we're going to be working with a 1 slit. That 1 slit is going to have over here and here. And then you have a choice with your software which one you're going to pick up. Sometimes depending on the light source and your angle, this one over here will be better than that one. And with these little ones that you make yourself, one she made out of a toilet paper roll, sometimes you have to get the angle right or you won't see it. And that's why sometimes it's better to buy a cheap one on the market. These are made, and then they have the wavelengths and the angstroms for what you're looking for there. Now, these are also used pretty heavily by gemologists. There are people who just study rocks, study gems, diamonds. So this is how they tell if the diamond is a good diamond or not so good. And I've got one of these somewhere here. It's a little one that you can buy and carry in your pocket. If you look at jewelers, they'll be looking at these diamonds. And if you buy, like I bought my wife a diamond for engagement, and then you take it to a jeweler, he looks at it and says, yep, it's good. The cuts are good, it's a good diamond, and it's worth $3,000 for it. Or he'll look at it and say, oh, that's a cheapie. You know, somebody cheated you a zircon, for example. That's worth $35. So that's how they tell. One of the 5 methods that they use to tell the worth of a gem. So that's what I was forgetting to go over is the first order, second order, and third order of the diffraction, how it goes out. That you have to know that angle or work with the angle. A lot of people think they can look straight through. It doesn't work like that. And you'll get very confused and very frustrated. So, okay, I think we'll wrap it up there.